A warm greetings from Madanapalli Institute of Technology and Science, Madanapalli, Annamaya District, Andhra Pradesh. So this is Dr. K. Lakshmi Khandan, working as an assistant professor in the Department of Electrical and Electronics Engineering at MITS. So the topic of my presentation today is electric vehicle and its charging stations. So coming to the flow of presentation, we can see that the various topics are introduction, types of electric vehicles, types of four-wheeler electric vehicles, all types of electric vehicles, the electric vehicle components, types of two-wheeler electric vehicles, and the charging methodology. So, coming to the introduction, first we'll know what is electric mobility. This electric mobility is also called as e-mobility. So here the vehicles are being propelled by an electric motor in which electric current is being supplied by the battery. And here the conversion of internal combustion engines is being done to electric motors. So you can see that there are various types of electric vehicles. The mainly used electric vehicles are two-wheelers, three-wheelers, and four-wheelers. So coming to the types of four-wheeler electric vehicles, here we can see that we are having conventional vehicles, hybrid electric vehicles, plug-in hybrid electric vehicles, and electric vehicles. So coming to the first type of conventional vehicle, we can see that these vehicles are using internal combustion engines or the IC engines. So here in this type of vehicle, the fuel is injected into the engine and the fuel is being mixed with the air before it is being injected to start the engine. So here the consumption of the vehicle is mainly the fuels. The fuels may be a petrol or diesel. And these vehicles are driven by internal combustion engines or the IC engines. The main advantages of this vehicle is that it is easy to refuel and it is having a long driving range with higher speed. At the same time, it is also having some disadvantages like it is giving out more emissions of carbon dioxide. Similarly, the cost of the fuel is also high. So coming to the next type of electric vehicle called the hybrid electric vehicles, we can see that it is powered by both engine and the motor. And the battery here is being charged internally through the engine. So the fuel used or the consumption of this hybrid electric vehicles is the fuels. So here the fuels are also the petrol or the diesel. So here these hybrid electric vehicles are being driven by the engine primarily and secondarily by motors. So this hybrid electric vehicles are also having some advantages like it is easy to refuel when it is required and it is consuming less fuel. At the same time, it is giving out less emissions. So coming to the disadvantages of this type of hybrid electric vehicles, we can see that it is giving less power and because of the usage of both engines and motors, the weight of this vehicle is much heavier. So coming to the next type called plug-in hybrid electric vehicles, we can see that the battery is being charged both internally and externally. And these type of vehicles run on electric power before using the engine. Similarly, these vehicles consumes both fuels as well as electricity. And these vehicles are driven by the motors primarily and secondarily by the engines. And the advantages of this type of vehicles is that it is easy to refuel, it consumes less fuel, at the same time it is giving out less emissions of carbon dioxide. Similarly, it is having some disadvantages like the price of the vehicle is much higher because of the usage of both engines and motors. Similarly, these are limited models to choose, and because of the usage of both engines and motors, the weight of the vehicle is being increased or it is heavier. So coming to the all type of electric vehicles or the all electric vehicles, we can see that these vehicles are powered only by electric motors and there are no engines. And a large traction battery must be plugged externally to charge this particular type of vehicles. Similarly, the consumption of these vehicles is only electricity, and these vehicles are driven by the motors primarily. At the same time, these vehicles are having some advantages, like it is environmental friendly, it is having a low maintenance cost, and these type of vehicles are being supported by the government. Similarly, it is having some disadvantages like lack of charging stations, it is having a short driving span or range, and it is giving low speed, and the weight of the vehicle is also more. So here we can see some of the electric vehicle components. The main components which is present inside the vehicle are the DC to DC converter, the onboard charger, the foot pedal, the vehicle networks, the AC to AC motor or inverter, the gearbox, oil cooling pumps, power distribution, relay fuse box, gearbox, AC motor, battery pack, etc. etc. So, if you go to the electric vehicle components in depth, we can see that the major components are the DC to DC converter, which is being connected to the supercapacitor. At the same time, we can see that this DC to DC capacitor is being connected to the propulsion of the battery, and we are having an onboard charger which is being supported by the vehicle. So, whatever battery you are using inside the vehicle, we are having the main battery as well as the auxiliary battery, right? So, this auxiliary battery stores the charge and it gives power to the vehicle when it is required. So, coming to the types of two-wheeler electric vehicles, we can see that we are having two types. The main types are the conventional vehicles called the bikes or the bikes, which is being fueled by either petrol, and the second type is the electric vehicles. So these electric vehicles are mainly scooters, or it may be an e-scooter or else an e-bike. So coming to the petrol vehicle, we can see that these vehicles are non-eco-friendly and it is having a high maintenance. Similarly, these vehicles runs on petrol, and since the cost of petrol is higher, it is having a higher running cost. At the same time, it produces harmful emissions like carbon dioxide, CO2. But at the same time, it is having an advantage that it gives a long run. That means you can have a travel for a longer distance, and you can have an easy refill of the petrol. So coming to the electric vehicle, we can see that it is eco-friendly. It is having lower maintenance cost, and this vehicle runs on battery, and we can save a more amount because the running cost of this electric vehicle is very less, and it is not giving any emissions like CO2 or the carbon dioxide. At the same time, you can see that since it is having less charge, you can use this vehicle only for a short span, and you can easily refilling or recharging of the vehicle is not possible. So coming to the electric vehicle stock in the scenario 2018 to 2030, we have seen that many countries, they are given proposals to ban internal combustion engines by 2030. That has been decided by the Indian government. Similarly, France, they have taken as 2040. Similarly, Germany, it has 2030. So most of the countries like Germany, India, Ireland, Israel, they want to ban the internal IC combustion engines by 2030. And similarly, Norway has taken the proposal to ban the IC engines by 2025, and similarly Scotland by 2032 and UK by 2040. So coming to the charging methodologies, because whatever vehicle we are using it, that vehicle has to be charged. So there are various methods of charging the electric vehicle. The first one is the onboard charger by using an AC charger. So here we are having two subtypes called the slow charging and the overnight charging. Similarly, coming to the second type called off-board charger or the DC charger, you can see that this is also called as fast charging. Similarly, the next type is the battery swapping. So here we will have the requirement of standardization and the size rating on communication protocols. So as I said, the first charging methodology by using an AC power, you can see that whatever AC power you are having, that AC power can be taken from the substation or the AC charging station, which is directly given as AC power to the electric vehicle. Here it is, we are assuming it to be a car. Similarly, the same AC power can be converted into DC in a DC fast charging station, and this DC power is given to the vehicle for usage. So the next level, you can see that in the various charging methodologies, there are various parameters to be taken into consideration, like the charge method, nominal supply voltage, maximum continuous current, the output power, and the estimated charging time. So in your first type, you can see you are having the AC level 1. You can see that it is giving taking a voltage of 120 volt single phase AC supply. So in which it is taking 12 amps of current, and it gives an output power of 1.4 kilowatts. Similarly, the second option, we are having a 16 amps power supply of consumption, and it gives a power of 1.9 kilowatt. And the estimated time for charging the electric vehicle is approximately 17 hours. Similarly, coming to the next type called AC level 2, you can see that you are having a nominal supply voltage of 208 to 240 volt AC single phase power supply, and it is taking 80 amperes of current and gives an power output of 19.2 kilowatts. And the power charging time taken for the vehicle to get charged is approximately 7 hours. Similarly, coming to the next type called DC level 1, we can see that here the nominal supply voltage is 200 to 500 volt DC, and it consumes of approximately 80 amperes of current and gives an output power of 40 kilowatts. And the estimated charging time is approximately 1.2 hours. Similarly, coming to the last type of charging methodology called the DC level 2, we can see that the nominal supply voltage is approximately 200 to 500 volt DC, and it is consuming 200 amperes of power supply and gives an power output of 100 kilowatts. At the same time, the charging time taken by this method is approximately 20 minutes. So the first type we have seen in mode 1 or charging mode. So here we can see this charging can be done from a standard power outlet with a simple extension. At homes we can do it. Similarly, this type of charging involves plugging an electric vehicle into a standard household socket. And this method of charging does not provide users with the shock protection against DC currents. So the second mode, we have seen that in the second mode, the charging involves the use of a special cable with integrated shock protection against AC and DC currents. Similarly, in this type, the charging cable is provided with the electric vehicle. Unlike mode 1 charging, the mode 2 charging cables have been built with protection inside the cables which protects against the electric shocks. So the mode 2 charging is currently the most commonly mode of charging the electric vehicles. So coming to the mode 3 of charging mode, you can see that this method involves the use of a dedicated charging station or a home mounted wall box for electric vehicle charging. So here both provides shock protection against AC and DC currents. Similarly, in this mode, the connecting cable is provided with the wall box or the charging station, and the electric vehicle does not need a dedicated cable for charging. So similarly, this charging is currently the preferred and the most oftenly used means of electric vehicle charging. So coming to the last type of charging mode, you can see that this mode is often referred to as DC fast charge or the just fast charge. However, this is giving different ratings of charging modes. The main charging modes are 50 kilowatts and 150 kilowatts methods. Plus, additionally, we are having, and it is having a proposal of 250 kilowatts and 400 kilowatts uh, charging stations. So here we can see the diagrams of the various modes called the mode 1, 2, 3, and 4. So these are the various four modes how the charging of an electrical vehicle is being done. So currently the mode 4 is the frequently and mostly used method for charging an electric vehicle by using 50 kilowatts and 150 kilowatts charging stations. In future, maybe in a short span of time, we can have 350 kilowatts and 400 kilowatts charging stations for charging the electric vehicles. Thank you.